Hello, everybody. My name is Noah Helman. I'm one of the co-founders of Industrial Microbes and the CEO, and excited to tell you today about sustainability and the circular economy. I'm sure you've already been struck by lightning 9 times already, so hopefully this is number 10. Thinking about the circular economy, obviously we need to find a way to take our waste products and turn them back into the raw materials from which we're going to manufacture all of our everyday products. We're specifically focused on methane as the material that will be used as the recycled carbon that we can turn into all sorts of different products. And the reason is that methane is a greenhouse gas that is 86 times worse than carbon dioxide for global warming. So repurposing that as a raw material from which we can make chemicals and materials makes a lot of sense. It comes from all sorts of different biogenic sources: wastewater treatment, landfills, organic waste such as animal waste. You can see my buddy the cow here. And what we're doing at Industrial Microbes is to engineer strains of bacteria that can turn methane into all sorts of different chemicals. We do this in order to prevent it from ending up in the atmosphere, but also it's a very low-cost feedstock from which we can make the chemicals that we use throughout our economy. Now, the key to doing this scientifically was to develop a technique that we could use to turn E. coli into a synthetic methanotroph, one that can consume methane as a raw material. The key to that was developing the ability to use this enzyme called MMO in our strain. And it turned out that this had been tried since as early as 1990. And on the early days of our company, we called up the expert in the field and asked her, how are we going to do this? We want to turn E. coli into a methane eater. And she literally told us to give up. She said, stop what you're doing. I've had grad students and postdocs thinking about this for years. It's never worked. Well, a few months later, my co-founder and CTO, Liz Clark, figured out a way to do it. And since then, we have developed the ability, through her leading a team of engineers, to actually get this enzyme operating at commercial rates. So for the first time, it's possible to take E. coli and convert methane into methanol in E. coli, and then that molecule can be turned into all sorts of other complex products. So today, we're able to make a variety of different products, such as this one that I have here, showing you on the slide. We've sent these out to industrial partners, and they have validated the quality and the purity of this product. Our early products include things like acrylic acid, which is used in diapers and paints, coatings, adhesives, cosmetics, and so forth. We're also working on methacrylates, used to make things like acrylic glass, commonly known as plexiglass, and acrylonitrile, which is used to make things like carbon fiber and synthetic rubber and all sorts of hard plastics for lightweighting vehicles, for example, and plenty of others that are in development. I'd like to invite you to think there are all sorts of things around us that can be remade using a circular economy approach. We have to change the way that we make all sorts of different chemicals and materials, and we need to start from the waste materials that we have in our society today. So a key part of this is that it has to be cost competitive, and as a result, we've done a very detailed techno-economic analysis of what it would take to use methane as a feedstock for the chemicals and materials industry, and happy to talk to you about that after the talk. We've also published a white paper on our website, so please come find me afterwards. Would love to chat with you more about it. Thanks very much.